All right, we're going to be doing rational expressions. We're not going to do anything about solving or anything. We're going to be talking about excluded values. We're going to talk about what this even means, all this stuff. What is a rational expression to begin with? And then we'll talk about the excluded values, okay? I'm going to actually copy this word rational and move it over here so we can kind of dissect it, okay? The word rational has a root in it right here, the word ratio. Okay? And a ratio is another name for a fraction. Okay? A ratio usually has the word, if you're going to mix something with a ratio of 2 to 1, that's a fraction. Sometimes you can write it 2 to 1 like that, or you can write it with the letter 2 in it, but it's also a fraction. Okay? So the word rational expression is going to mean an expression with fractions. And so let's talk about the excluded values right now. You know that if you are dividing, if I take 0 over 2, that means 0. But if I have 0 down here on the denominator, this is not possible, okay?
Should be undefined.
You've also learned that null set name, which is undefined, exactly. So this is undefined, and we can't do it. And so if we had a rational expression with, let's say, letters, 2 over x, I could plug values in for this x, but the only one I cannot plug in is 0. So x cannot be 0, and this is our excluded values.
Oh, okay.
So anytime it makes the denominator be 0, we can't have it. So if we had something like 2x plus 5 over x minus 1, what could I plug into that x so I would turn that whole denominator in for 0?
You could do a positive 1.
That's right. So x cannot equal 1. If it did equal 1, then this fraction would be dividing by 0, and we would be able to do it.
Right.
So this is our excluded value.
Oh.
Okay.
Okay.
So let's do one like this one, where I have 5 and I have an x squared minus 1. So that means that this part here cannot equal 0. So what values, if I do x squared minus 1, I can't have it equal 0 or we'd have a problem. So let's see what kind of values would make it turn into 0. Okay? I'm actually going to give myself some more space. So I'm going to move it up here. Okay. I'm going to add 1 to both sides to solve this for the x squared. Are you with me so far?
Uh-huh.
I'm going to take the square root of both sides. This is review from a while ago when we did square roots. So whenever I take a square root of both sides, I'm going to have a plus answer and a minus answer. Are you with me?
Uh-huh.
Okay. What is the square root of 1?
You can't do this. 0.5? No.
What times what equals 1?
1.
1. Okay. So that means that the excluded values will be positive and negative 1. So we're going to go like that to show that x cannot be positive 1 or negative 1. Let's test it. If I plugged a 1 in there, I'd have 1 minus 1, which is 0. It would be bad, right?
Mm-hmm.
Okay. If I plugged a negative 1 in there, we'd have negative 1 squared, which would turn it into a positive 1. And I'd have, again, same problem.
Okay.
Okay. So this is my excluded values.
Okay.
Okay. They are not going to write this not equal in here. They're just going to say the words, the excluded values are. And so this would be the same thing as saying the excluded values are. And so this symbol would be able to tell you that x cannot be.
Oh,
that.
okay.
Okay. So let's do another one bigger. Okay.
Right.
6x squared minus 5x plus 1 over 10x x squared plus 1. Okay?
Okay.
So if we had something large like this, if I had this being 0 and I multiplied it by that, it would become 0, correct?
Right.
Okay, so what makes this portion be 0?
Dividing by...
Let's ask this question. 10 times 1 equals 0.
0.
Okay, so x cannot equal 0. Are you with me so far?
Right.
Okay, so then let's go to this one. Right here.
Negative 1.
So if I plugged a negative 1 and I did negative 1 squared, that negative 1 is going to turn into what? Positive 1. And so, what else? So I I can't put negative 1's the only thing that will be subtracted to make it, and I can't make that become a negative. So this will never become 0.
Okay,
Does that make sense?
that makes sense.
So only x squared, which means x cannot be 0. The way we're going to do that is anytime you have something multiplied, we're going to do this. 10x equals 0 and solve it, and x squared plus 1 equals 0 and solve it. This one, if I subtract 1 from both sides, I'm going to get x squared equals negative 1. I'm going to take the square root, and you cannot take the square root of a negative number.
Right.
At least not yet. You'll learn that you can later in later in your algebra life. But right now, for the real numbers that we're dealing with right now, we cannot take the square root of a negative. And so at that point, you'd stop and say, well, I can't do it any further. This would be the only thing that would give us an exclusion, because over here, dividing by 10 is possible, and x would be 0.
Okay.
Is this making sense to you?
Yeah.
Let's do another one.
Okay.
Let's do a bigger one like this one. Okay. We're going to find the excluded values, and so we're going to figure out what makes this equal to 0. So we're going to put this equal to 0, and what am I going to do?
Okay, so you're going to do 0. Oh, sorry. Minus 5 for that one.
Good.
That's going to... And then you're going to do plus... And then you're going to take the square root, right? No, you can't do that.
This is just 3 times x. How do I undo multiply?
Oh, you're right.
Very
So
good.
divide by 3.
X is going to be 5/3.
And then you...
And then that. If I plugged 5/3 in there,
It would...
in this case, negative 5/3. These are going to cancel.
Right.
Leave you with negative 5
Right.
plus 5.
Is 0.
0, and that would be a problem, right?
Yeah.
So to make that so it's not a problem, we're going to make sure that x is not equal
Okay.
to
Can
negative.
we do another one?
Yes. Let's do another one like that one, and then we'll move on to some bigger ones, okay?
Okay.
All right. Let's do this one. No, let's not. Let's do that one. 5 over 3x minus 4. What's the excluded values, and what do I do?
Okay. So you're going to do plus... Well,
So we'll have 3x minus 4 equals 0, and we're going to add 4. That's right.
and so you'll have 3x equals 4. Divide by 3. Divide by 3. X equals 4 over 3.
Very good. And if we plug that in, these 3's are going to cancel.
So
right?
it'll be positive 4 minus 4, which will be 0.
Very good. So we're going to make it not equal to that so that it would... Well,
Okay,
Okay.
that makes
Let's
sense.
do one where we're going to have some extra... let's do one like this one.
Okay.
All right. 2x squared minus 8x plus 8 over x squared minus 5x minus 14. And we're going to just jump back to something we did earlier, okay? Maybe we're not.
Okay. Oh, what?
We're going to have to break this up into its pieces so that we can find out where they equal 0. So that means we're going to leave this one alone. We'll be doing another lesson where we do something with this, okay? So I made not enough room here, so let's do this. So we're going to come over here, and I'm going to leave the 2x squared minus 8x plus 8. We're going to factor this. You learned factoring a couple lessons ago.
Okay.
And so we did that box method, if you remember.
Yeah.
And we put the x here and the x here.
Oh, okay. So then we'd have like negative 7 times 2, or 2 times negative 2 times.
Which one do you want? Which one do you want to be the negative? The 7 or the 2?
The 2.
2. So if we did this, this would be 7x, right? Actually, let's do this. And this would be negative 2x.
Which
Makes 5,
which
right?
makes 5.
Okay.
Yep.
So then, what do I write here?
Plus 5. No. Plus 7.
Good.
And then x minus 2.
Okay, so now, what makes this become 0?
-7.
Okay, so x cannot be -7. And what makes this become 0?
+2.
+2. Okay, so these would be our excluded values. Because if I plugged in, let's just try it. If I plugged in a 7 here, -7, excuse me, I'd have -7 plus 7 and -7 minus 2. Doesn't even matter what this one is, because this is 0, and 0 times anything is 0. Okay? If I came in this one instead, I plugged in a 2.
Right.
This is 0, that's 9, but it didn't matter what this was, because 0 times whatever is 0. Okay? Let's do this one. We're gonna, looks like they kept the numerator the same, because at this point it doesn't really matter. This lesson, they're not dealing with the numerator right now, or the top of the fraction.
So is this going to be the same as the last one or a different way?
It's going to be the same thing, but they've already split it up for us. Okay? So they've already split up the denominator for us.
Okay.
Okay, so we don't have to split it up. Let me come in here, and we're going to keep the numerator. Oh, since they've already done it, I'm sorry, I don't need to do that part. Since they split it up, we have these two pieces, right? What makes this piece become 0? 2 times what gives us 0?
0.
So x can't be 0. We could solve this one, say this equals 0, or maybe you can plug something in to make that become 0.
-8.
What squared minus 16 would become 0?
Oh, okay, so what squared minus 16 would become?
Or we'll just do it this way. What minus 16 equals 0?
16.
Okay, so what squared makes 16?
What squared makes 16?
3 squared makes 9. What squared makes 16?
Oh, 4 squared.
4 squared equals 16. Okay, is there something else squared that equals 16?
8? No, because that's 36.
So we got 4.
What else squared equals 16?
Is there any negative squared that equals 16?
I guess -8? No, -4 and -4.
-4 and -4 become positive 16,
16, right?
Okay, now if you couldn't do that, look like you were having a little bit of struggle. If you couldn't think of some number, then just come out here and go x squared minus 16 equals 0. Let's just solve it.
Okay.
X squared equals 16, right? Take our square root. When we take the square root, we have a plus and a minus. So we have a positive 4 and a negative 4. Okay, so if you couldn't look at that and say, oh, yeah. But maybe you could now. Maybe if I had x squared minus 9 in the denominator of something like that,
okay.
What squared gives you 9?
And -3 and positive
3. Now that you've had that experience, you maybe can just jump to the answer. Okay, so we did another one. If we said x squared minus 49 over something like 2, what would be the excluded value on that one?
-7 and positive 7.
Yes. And then if we did this and we put an x there, what else? What makes this become 0?
Times times 0.
Yes, just plain old 0.
Okay.
Okay?
Okay.
All right.
I think once I watch the video.
Yeah, I think you will. Yes. So, we just did rational expressions. We didn't simplify them. We didn't solve them anyway. We just looked at the denominator and found out what makes them be 0 because we can't divide by 0. So we're going to have to do the excluded values. This textbook is calling them the excluded values. Other textbooks, you might just need to call it domain, or to find the domain. And so this would mean that if I said that x can't be plus or minus 7 and 0, I'm saying that x can be everything else except those 3 numbers.
Okay.
That's a lot of numbers it can be.
Yeah.
Compared to what it can't be.
Right.
Okay? All right. We're done.